So at this point we have achieved a step where we can make a comparisons of between my project and other projects. I have drawn a table with 124,000 projects, $37 billion. I have made an analysis only on a few projects. Of course, there are more on cancer. Of course, this evening I am not going to analyze 124,100 projects. I can just make a comparison with one project, taking the one that has been considered the best by the most important institutional bodies. At CERN in Geneva, last February, from the 2 to the 4th, 2010, a conference was held, and Actual Pet was a project which was awarded. So I'm going to make a comparison between my project and the Actual Pet and see which is the best, and if my project is better than the Actual Pet one. So that is the Actual Pet project as the following. There are two modules, 10 centimeter long, 3 centimeter wide, 6 centimeter thick, and to build a ring of 10 centimeter long we need 70 of these, because you need to build a circle. If it is 3 centimeter, generally the diameter is 70 centimeters of a circle, so 70 per multiplied per 3, 14 divided by 3, you get to 70 small objects, 70 of these small objects, which should capture all photons. But consider that one of these objects costs $50,000 only for crystals and fibers, without considering the cost of electronics. Second point, if I have 70 pieces, you have $3.6 million only for material. Then consider you have electronics and other connectors, and I only built 10 centimeter long piece. If you have to, if you need 40 of them, then you get to $50 million plus electronics and the rest, and the cost would double and get to $100 million. Then, considering effectiveness and not cost, with a 3 centimeter wide piece that is consisting of 1.5 centimeter crystals and 1.5 centimeter fiber, the effectiveness is 50%, so this will not lead to screening and early diagnosis. Then one other point, you can clearly see that 3 centimeter wide are added to other centimeters for cables and connectors. Photons are not captured by connectors and by cables, so the effectiveness there is once again reduced by 50%. These notions can be actually understood by a child, because these are very basic notions. If you wonder how could we think of implementing a useful project for patients, starting from these basic principles of a detector which costs 50,000 euros for crystals, and then you have to build the whole circle, and then at this point the most important thing to do is to ask directly the author, why did you do that? And I actually asked the author why did he implement this project, and I would like you to hear his answer. So I asked directly Joram, the author of the project, what did he answer? What did the author reply? So I asked him, is it a project for cancer research? And I asked him to repeat his answer 4 times. He said, no, this is not a project for cancer research, but it was awarded with the first prize for cancer research project. And he was very clear in his answer, and I've got the interview, and his answer was, no, not at all, it is not a cancer research project. Absolutely not.
This is not a cancer research project, not at all. No, we have never the word cancer here. No.
So it's not a cancer research project.
It is a PET instrumentation development, and not more.
So why do people deciding which project to fund do not ask researchers, what is your direction, what is your objective? When I left Dallas to come here, I had a destination in my mind. So you go through a path and you reach a destination. But if you do not know which is your final destination and no one wonders what is your destination, I will give you the script of the complete interview, and you will hear the question, what is the future with this project? The answer is, I don't know. Actually, we are implementing this project, but we don't know what is the final aim. Then we ask companies if they need it. Otherwise, I turn to another project. And you see that there are so many institutions involved. 1, 2, 3, 4, 5, 6, 7, 8, 9 international institutions from all over the world, from the United States, and no one wonders what is the application of this. Why, I asked Jerome, why do you measure spatial resolution and you keep on looking for that 10th millimeter of spatial resolution while you already have recognized there is a problem with collinearity and the positron which meets the electron after 4.5 millimeters for the brain? Yes, that's true, but that's because my boss told me that. My boss, and where is your boss? My boss is in Spain, in Valencia. So that is the way things go on. So no one knows why this project was awarded. So that is the poster that has been presented over these days in a conference that is, I think, in Knoxville this year, close to where I live, in Tennessee. And I can read the name of sponsors. Madame Curie Association. And I think that all these people from the group of Madame Curie Association are convinced that this project is actually a cancer research project. Why should they fund this project if it is not a cancer research project? The author himself states that it is not a cancer research project. So I think we should actually make a comparison between researchers. And at CERN, I tried to explain this point because I had a chance to deliver a presentation, and I asked the author because Jerome said that this was not used for brain study, but they wanted to work on a whole body, 70 centimeter diameters, and compare it to the performance of 3D CBS. And I asked him how much will it cost, and the final cost will be, as I've just said, 100 million euros. So you see that this project has neither rhyme nor reason. These things are really senseless. We actually fund projects not in a logical way. The logical way is there is an obstacle, we try to overcome it, we try to make an analysis. I remember at CERN there was Professor Danilo Vera from Cuneo and Margaret from the United States. We met after the conference in the director office. He was the scientific director of CERN, and I asked him, why did you award a prize to Axial PET? And he replied to me, actually didn't know what to say to me, and said, but because it was a nice tool. Yeah, I replied, actually this is not a scientific reply at all. You can't say it is a nice tool. Then I could argue that my technology, this tool is even nicer. So you see that my technology, this tool, has been considered a masterwork because such a small card by IBM with 2,200 components, 20,000 contacts that I managed to connect only in 8 layers of signals by using, and that is the key point, some very low cost technologies, standard technologies, not leading edge technologies or bleeding edge technologies. Leading means in the forefront, but using standard ordinary technologies with through holes and so forth. So some press releases were issued stating that I designed this technology and it was working at the first round with the first implementation of the first prototype. So 20,000 components were arranged in a very clear order in my mind, and they worked at the first application. So thinking of all things we need to do to achieve a result, that is the way to work. So when talking to Joram or to other people and ask what is your final aim, what is your final application, their answer is not clear. They do not have any answer. So that is the problem that revisers should tackle. That is why we need a scientific debate, a discussion between colleagues. We need to question each other and verify if the project has an objective. We have not reduced death rates for cancers because the objective was not set at all, because we are not even asking, I fund your project, what do you give me in turn? So that is what we need to do, ask what is given in turn when funding a project. Thank you.